Hey everyone, I'm going to be going over the solutions to the fall 2019 midterm 2. This test is, I don't have much to say about it. We're just going to go over it. I'm going to start with problem 1 in this video. So first, we're going to consider the following class, which uses our project 1 Enigma. I will give you a moment to maybe pause the video or read this. And so what we can see is basically we have some class dicey, and the main things that have are some machine, match, whatever, and this private int data, as well as the alphabet, which is digits. And when we make a dicey, first we're going to set the machine to be some new machine object, right? Then we're going to put in some rotors, whatever. We're going to set them all to the 0 setting. And then we're going to set the data variable to be data. And so that's what happens in the constructor. And importantly, we have both this hashcode method and this equals method. And so really what this problem is all about is figuring out when is a hashcode valid. And as we recall, the important thing for a hashcode to be valid is that if two objects are dot equal, right? If they're considered equal by the dot equal method for that class, then they must have the same hashcode. Must have same hashcode. And if you're a little confused behind the logic for this, let's just take a moment to imagine maybe that we have, some hash set, right? And let's say we have this cat object. And let's say cats are considered equal if they are the same color and their names are the same. And so this one is named Otis. And let's say he's 2 years old, whatever. And then let's say we have another cat also named Otis. And it's 4 years old, right? So if the equals object just checks to see that the cats are the same color and they have the same name, these ones would both be dot equals. However, if the hash code, let's say, took their color and their age, they would not have the same hash code. So what happens if we put this Otis into the hash map? Well, let's say this Otis gets put into, I don't know, if there are 4 buckets, it gets put into bucket 1, whatever. And then we ask, hey, hash set, do you contain this Otis? And what we will do is we will take the hash code, right, to find out if I was Otis, which bucket would I belong in? And so we're going to compute the hash code. But like we said earlier, in this bad scenario, the hash codes aren't equal. And so maybe this one hashes to, I don't know, bucket 3. And so we go looking in bucket 3 and we say, oh, there's no, the thing we're looking for isn't in there. When that's not true. We did have a cat named Otis in our hash set, right? We considered them equal and we would have wanted the answer to say, hey, is this thing in there? Oh, yes, it is, because these are equal to us. However, because they had different hash codes, even though they're equal, we ended up with an invalid answer. And so that's sort of the logic behind this problem. And I think that's the main thing you need for a conceptual understanding. And so now let's take a look at this. Oh, the other thing about a valid hash code is that it's always going to be the same. No matter how many times you compute the hash code, it's deterministic. Hash code is always same. And so the first thing is, when used with the hash set, right, if we try to put dicey objects into one, it doesn't work properly. Why not? And so the main thing to check is our hash code valid, right? And now let's take a look at these equals and hash code methods. Let's say we have 2 diceys, which are equal, right? They have the same data value. Maybe both of their data is, I don't know, the number 3, right? So this is D1, we'll call it dicey 1, and this is 2, and their data is 3. Sorry, it's kind of squished. And it looks like this. These objects are equal. Now, are we guaranteed that these objects will always have the same hash code? Well, let's look at this. We see that the digit string is set to be the integer.toString of data. So far, so good. We're working with data, right? Which is the same thing that equals tricks. But then we convert it using our machine. And so one thing to notice is that in the constructor, the machine itself is always sort of initialized to an equivalent machine, right? Like the constructor doesn't take in anything that really changes how the machine itself is made. And so we can assume the rotor list and this are equal across both. However, what do we know about the Enigma class and the Enigma project? Is convert going to be the same thing every time? Is it going to be the same every time? It won't be, because that's the whole point of the Enigma, right? Is that when you convert something, it gets like all wacky and convoluted, and that's how it becomes a great encryption. And so we realize this does not work because number one, the hash code is not always the same, right? If you compute the hash code over D1, maybe the first time you'll get 3, or sorry, you'll put in 3 and get out 5, and the second time you'll put in 3 and get out 9, because that's the point of the Enigma. So not only does it fail because of this, it also fails because D1 and D2 would not be guaranteed to be equal, because even though they have the same data and they're working with the same like initial machine settings, right? At first, they have the same rotors in. The machines themselves could be at different states. The rotors could be turned to different settings. And so we see that it also fails this condition. So that's sort of the explanation for why it doesn't work. I sort of said it out loud, so I'm not going to bother writing it. I'll just say it's bad. I probably wouldn't have got points on the actual midterm, but you heard what I said. And so now the question is, how can we fix the problem in A? And so the thing we were saying was that sort of, the problem is, even though the machine itself has the same rotors and everything, the setting could be changing every time, right? The setting is not guaranteed to be in the same state when you convert every time and get the hash code every time. So you're going to get something different. And so is there any way, given the lines that we have, knowing that all we can do is move one line, is there anything we can put to make the hash code be the same every time? Anything we can do to guarantee that the setting is always the same and we don't have some different state that's going to affect the conversion? And this is the solution. We want to take line C, right, which sets the rotors to be 0, and put that right here. And so the solution here is to move line C to before line E. Great. That is part A and B. Moving on to part C. Suppose we add a new method to the corrected class from B. This also causes problems with uses of dicey objects in a hash set. Why? And so now again, let's say that we're working with the corrected class from B now, right? So it has this line set rotors here, right? But now what's the problem if we're able to change data? Let's take a moment to think about this one. Well, again, we said it's really important that the hash code is always the same. Why is this? Well, going back to our Otis example and our cat example, to just think about the sort of basic concept, let's say we put Otis in and the age is 2. And let's say now the hash code uses the age, whatever. If we are able to change the age, right? If we could do like Otis.birthday and Otis's age became 3, right? We're looking at this exact object and we have it update its birthday. And then we ask later, hey, was Otis in the hash map? Is this Otis that we know in there? And using the age, we would go look in the appropriate hash set. We would take a hash code that keeps in mind the age. And because the age used to be 2, but now it's 3, Otis might end up in a different bucket. And so maybe now with the updated age, Otis belongs in, I don't know, bucket 3 again. And so we go looking there and Otis is not there. And so the premise of this is that if you have an object in the hash set already, and then you change one of the attributes that the hash code is computed based off of, now it's not guaranteed that object would have ended up in that bucket to begin with, right? And so let's think about this example again, going back to sort of the actual problem at hand now that we have the conceptual understanding. What we're going to see is that if we can change the data attribute, it's possible we could put some dicey into our hash set with, let's say, data 3, and according to the hash code, which is computed on the data, right? We take the data into account. It will belong in, let's say, one bucket. But if we change the data, now it's going to belong in a different bucket. And so we have this inconsistency where we don't know where things belong anymore because the hash code is changing when we change data. And so that's why this doesn't work. Changes hash code. Great. Now, what if we just completely replace lines E and F with return data? Will this work? Why or why not? So we're going to say just take the whole hash code thing and turn it into set rotors, return data. So let's first check. If two objects are equal, will they have the same hash code? Well, sure. If two objects are equal, all it checks is that they have the same data. And if the hash code is just returning the data, then the equal objects would have equal hash codes, right? These two objects are equals because they have the same data. And if the hash code just returned the data, they'd also have the same hash code, 3. The other thing is the hash code always the same? Well, assuming we're working with the corrected version and not this stuff that we had there, it's a separate part of the problem, then the hash code's never going to change because data will never change. And so this does work. Satisfies both of our important properties for a hash code. Then we want to remove the overriding of dot equals and the corrected class from B. Will this work in a hash set? Why or why not? And so this requires us to know what the default equals will be if we remove this override. The default equal says two objects are equal if they are the same object. If they point to the exact same thing in memory, they're equals. Okay, well, that means in this case, these two dicey objects, which are separate objects in memory, right? We created them both with the new keyword dicey. D1 equals new dicey, and we did dicey D2, right? They're separate objects. These would no longer be equal. Okay, so then we don't really have to worry about that sort of like equal objects having the same hash code because D1 is only going to be equal to itself. And of course, D1 has the same hash code as itself, right? And we've also determined the hash code method is not changing here, right? We're only changing the equals, and that's always the same. So we've satisfied both of these. But the main thing to understand here is that overriding or not overriding equals means we just check to see sort of things are only equal if the objects are equal, if they're at the same address. And so an object must have sort of, it's going to compute the hash code the same way as itself every time, if that makes sense, right? D1 is guaranteed to compute the same hash code every time. So D1 is equal to D1, and D1 has the same hash code as D1. So this works. Now, what about the other way around? What if we remove the overriding hash code? Is this going to work? If we remove the overriding of hash code, it's going to use the default, which computes a hash over sort of where the object is in memory. And so this, again, is going to return basically something based off where the object is or like the instance that we have, which means D1 and D2, which are separate objects, would have different hash codes because the hash code, the default hash code, if we remove this overriding, is going to sort of look at the address and the objects themselves. And so they would have different hash codes, even though they're considered equal, according to our overridden equals method, and this would not work. And this is problem 1.